proportions are used in a lot of different places in mathematics. I personally use proportions, well, obviously doing proportion problems, but also when I solve percent problems and when I solve similar triangle problems, which is a geometry concept, right? I use proportions. So let's define what a proportion is first of all. The basic definition for myself, I would say that a proportion is the comparison between two equivalent ratios. And I think this is where it gets a little bit messy for students, or a little complicated, I guess. It's the fact that ratios have more than one way of being expressed. And there's a way to write down a ratio from a word problem into an exercise problem so we can solve it. And I think those little details are what make proportion problems difficult. It's not really the fact that it's a proportion. It has more to do with the way the ratios are set up and the way that they have more than one way of being expressed. So if you remember, a ratio can be expressed in words, like in a word problem, right? Or it can be expressed with the colon, the two dots, right? A value on one side, the colon, and then a value on the other side. Or it can be expressed in a fraction form. And that's typically how we will work with proportions. We'll work with the ratios of that proportion in a fraction form. So I have an example here. 2 of something compared to 3 of something else. I didn't put units or anything. I didn't put like feet to inches or miles to gallons or nothing like that. This is just an exercise to show you the basic concept of proportion. So my first ratio is 2/3. That's my first complete ratio. The second equivalent ratio, and it's equivalent because we have an equal sign, the second equivalent ratio is not complete. It's missing one of its values. And so this is basically what a proportion will always look like, a proportion problem. They're going to give you 2 ratios, and that's basically going to be 3 numbers, right? Or actually a total of 4 numbers, but there's always going to be one missing, okay? And it's our job to find the missing number. So I just put an x in lieu of the missing number. That x would be called a variable. It just takes the place of a missing number, okay? All right, so there's a couple of ways to solve these, okay? I'll show you a few, and then I'll show you the one that I like the best. The one way that I like, it's a handy tool, I think, is if you can recognize the relationship between 3 and 15. If you can recognize that, that's great. You can get to the answer much, much quicker. So what I mean by that is there's a factor that is common between the 3 and the 15. And I don't know if you guys can see it, but we did this when we were adding and subtracting fractions, right? I would say the 3 is getting bigger. Bigger means multiplication. 3 times some number gives you 15. And that number is going to be 5, right? So if I take that same factor that I have here in the denominators, and I do the same operation in the numerator, it would give me the correct value that I'm looking for. So 2 times 5 would be 10. And so 2/3 is equal to 10/15. And that would be correct. But again, this idea of finding a common factor between the two sides of the equal sign, it doesn't work all the time. It works maybe, 60%. I don't know. It works a lot of times, but not all the time. And that's okay. It's a handy tool to have. And I say, if you're good with your multiplication tables and you can see that, you can get the answer and move on to the next problem. Why do more work if you don't need to? All right. But like I said, it doesn't work all the time, so let's talk a little bit more about what proportions are really talking about. There's a rule or a principle that is applied or used when we discuss proportions, and that principle is called the cross product principle, or cross multiplication rule if you want. So what that says is that if I was to multiply this equivalent proportion diagonally, so for example, if I was to multiply 2 times 15, that should be the same answer if I multiply the other direction diagonally, 3 times x. So let's write that down really fast here. So 2 times 15 should be equal to me multiplying the other direction, 3 times x. And for those of you who are familiar with algebra, you can see that that is an algebraic equation. I'm just going to make my equal sign a little bit more obvious. Okay, it's a simple algebraic equation. Let's go ahead and do it. 2 times 15 is 30. I'll just rewrite the 3x. We separate the 3 from the x with division. So we divide both sides by 3. And that would basically give us 10 is equal to x, or 1x. Now, if you don't know algebra, you don't need to. You don't need, not for this anyway. Later on you do. You will need for other stuff. But right now, to solve a proportion, you really don't need algebra. What I'm showing you here is what the cross product principle is trying to tell us, is that multiplying diagonally in one direction, that answer, 30, should give you the same result multiplying the other direction diagonally. Okay? So if x is 10, this would be 3 times 10. So 2 times 15 is 30. 3 times 10, we found out what x is also 30. So 30 equal to 30. These are two proportionate ratios. Okay? But again, I just wanted to show that for those of you who do understand algebra. If you don't, that's okay. We'll get to that later. So how do I solve these 100% of the time, if I want the answer 100% of the time? I showed you the one with the 5. That works some of the time. But the way that works every single time is simply multiplying diagonally. So in this case, 2 times 15. That's 30. And then you divide by the other number that you haven't used. And that's it. And that will give you 10. 30 divided by 3 is 10. So x is 10. But we already knew that. This is an easier one. I say it's easier because for those of you who are familiar or pretty good with your multiplication tables, you'll see the 5 in between the 3 and the 15. Okay, so let me show you one where it's not so clear or not so obvious. We'll take 5 over 20 is equivalent to 8 over x, 8 over some number, okay? Now this one is not so clear. I mean, I have a number on both sides of the equal sign, but I can't, there's no factor that I have, no obvious factor in the middle here. Okay, so 5 times 1 is 5, 5 times 2 is 10. I don't have a magic little key number in there. So I'm basically being forced to use that cross multiplication and then the division with the third number. So another thing to point out, this time my multiplication goes this way. The last time my multiplication was going that way. It doesn't matter. The idea here is that it just has to be diagonal, okay? The direction just depends on the problem that they give you, okay? So 20 times 8 is 160. Divided by 5, the other number that I haven't used, that will give me 32. Okay, so 8 over 32. 5 over 20 is equal to 8 over 32. All right? Now, these are just exercises. These are just examples to show you how to do the operation when you have a proportion all nice and set up for you, all ready to go. The harder part is setting up the proportion. I think this is where my students struggle more. Obviously, this little multiplying diagonal, dividing by the other number isn't really too hard to understand. It becomes a little bit more problematic when you have to decipher a word problem and then put that information in the correct form, in the correct order, and then solve your proportion. So it's setting up the problem that tends to be difficult. So let's take a look at this one. I'll read it. It's might got the top cut off a little bit here, but it says Tanisha can drive 44 miles with 2 gallons of gas. How far can she travel with 14 gallons of gas? So part of the problem here, part of the first challenge or the first step is to identify that this is actually a proportion problem. So imagine yourself taking a test, right? Taking an exam, and it's a cumulative exam, which means that there's different subject areas, right? Different concepts in math, for example. Say you're doing an algebra problem, then you do a geometry problem, then you have like a percent problem, maybe, right? And then you see this problem. And you're like, oh, what is this? See, in this video, it's real easy because you know that the whole video is about proportions, but when you're doing it out of context and you run into one of these, how do you recognize that it's an actual proportion problem? So the first thing to point out here is that there are 3 numbers. That's the first step into identifying what a proportion problem is. The first step is to say, well, I have 3 numbers, 44, 2, and 14. right? But that's just the first step. Just because you have three numbers in a problem doesn't mean it's a proportion problem. The other thing to check for is that two of the three numbers have the same unit of measure, okay? The same unit of measure. So what do I mean by that? 44 is talking about miles. The 2 is talking about gallons. And the 14 is also talking about gallons. So I have two values talking about gallons. I have 2 gallons and 14 gallons. So just to recap, how do I know this is a proportion problem? I have 3 values, 3 numbers, and 2 of those numbers are in the same unit of measure. In this example, 2 of them are in gallons, 1 of them is in miles. That is a proportion problem. And then they're asking me for a 4th value, okay? They're basically asking me how many miles. That's what travel means here, right? How far can she travel, or how many miles can she travel with 14 gallons of gas? So the first thing to do here to set this up, let's set up the units of measure in the way that they presented them to us. What did they give us first? Or maybe I should ask you or tell you, look for the first complete ratio. Okay, where's the first complete ratio? Because if you remember the exercises that we did, I always started with a complete ratio and then a ratio that was missing one of the 2 values, okay? So here the first complete ratio is the 44 miles to 2 gallons, okay? This ratio is expressed in a sentence form. Later we'll show you one with a colon, okay? All right, so 44 to 2, or miles, I should start with that first. Miles is being compared to gallons. And I need to copy that same order, okay? So actually, let me move this guy over here. Miles is being compared to gallons of gas. All right, so I know what I need to do is I need to make sure that I maintain this pattern, okay, in my second ratio. So I got the order. Why do I have miles on top of gallons instead of gallons on top of miles? Why? Because that's just one of the fundamental principles about ratios. Again, I talked about this earlier. It's the ratios that are difficult about proportions. It's not the multiplying and dividing. Okay, so I put miles on top because that was the first thing they gave me. I have to copy the order of the problem. Okay, so miles comes first. I put miles first. I put miles in the numerator. Okay, and then I write my other proportion in the same way. All right. So it was 44 miles to 2 gallons. All right, then they give me a third. They give me the third. So I identified the first complete ratio, and then they give me part of the next ratio. And they give me 14 gallons. So where do you think gallons are going to go? Right, gallons are obviously going to go where I have gallons written. So 14. Now we set up the problem. That's how we do it. Okay? Identify that it is a proportion problem, and that is by looking for 3 values. 2 of them will be in the same unit of measure. Okay? And then we write down the first complete ratio, and then we copy the second one to be in the same order, the same pattern, and then we just put the values in the way they give them to us. They gave us 44 miles first. It's in the numerator, 2 gallons second, and then we just got to situate the last value. So we're ready to solve. Remember, it's multiplying diagonally. In this one, it's this way. It just depends on the problem, right? So 44 times 14 is 616. Divided by the third number that we haven't used, which is 2. And 616 divided by 2 is going to be 308. And that's going to be our answer to complete this proportion problem. All right. So that's that. It's not too bad. So that was an example where, the problem had the ratio presented to us in a sentence. And the ratio itself was just 2 miles, using width as part of the proportion, okay? Now let's look at another one. That's a little bit different. All right, can you see that? There it is. It says here, the ratio of wins to losses for the Bears is 7 to 2. So here you can see that the ratio is being expressed with the colon, the 2 dots. Okay, we'll talk about that in a sec. If the team won 21 games, how many did they lose? All right. So is it a ratio? Is it a proportion problem? How can we find that out? Well, I start looking to count numbers, right? And I need to count 3 values. So I have a 7, I have a 2, and I have a 21. Yep, I got 3 numbers. Now, before we go further, what does a 7 mean? What is a 7 talking about? Or for that matter, what does the 2 represent? How do we know? We go back up to the top here. It says the ratio of what? Of wins to losses. The first part of that ratio they give us is wins to losses. In fact, I can already go over here and start with this. Because that's how they gave it to me, right? And I know that my second ratio is going to be in the same order, wins over losses. Okay? All right. Okay. Okay, so now the 7, being that it's the first number in the numbered form of the ratio, goes to the wins, which is the first in the written form of the ratio. Okay? So we have, this is going to be the wins. The losses is going to be the losses. The 2 is going to be the losses. And, okay, so we'll set that first ratio up. That is the first complete ratio. And so this is going to be 7 wins and 2 losses. All right? So now we have to set up the second ratio depending on what they gave us. And they gave us 21 games, but the team, okay, there it is, won 21 games. So where does the wins go? The wins go with the wins. 21 goes with the wins. And that's basically how we will set that up. So let me go ahead and put that problem back. Just take a look at it again, right? They give us the first ratio in words here, wins to losses. And then they give us the ratio with the colon, and we have to understand that the first value is the first one in the ratio that they give us. And the second value is the second part of the ratio. That's the thing about ratios, okay? All right, so here we have it set up. And it's the concept of doing it is easy. It's just multiplying diagonal, divide by the third number. So 2 times 21 is 42. And 42 divided by the 7, that will give us 6, okay? So basically what it's saying, so they gave us a reduced form of their win ratio, win to loss ratio, which is 7 to 2. But it probably means that they did play more games. It's just that, they reduce it down. So for every 7 we win, we lose 2, something like that. And in this case, they win 21 games, let's say in a season, that means that they would lose 6, okay? I think I'm going to do one more problem to show you, okay?